Good evening, dear students. So in the last class, we have completed structure of atoms. So we have completed two chapters. The first chapter is basics of chemistry. Okay, some basics of chemistry, and second one is structure of atom. So today we are going to start with the third topic, that is classification of elements and periodicity in properties. Okay, so do you know how many elements are there in our periodic table? Yes, how many elements are there in the periodic table? Do you know?
118.
Yes, 118 elements are there in the periodic table. Okay. Now, as we cannot study each element, 118 elements separately, so what they have done, they have classified them into different groups. Okay, they have classified them into different groups. So, what do you mean by classification of elements? Classification of elements is nothing but we are grouping the elements in different groups, okay, in tabular forms, okay, which are having similar property. So the elements which are having similar property, they are placed together, okay, they are placed together, and which are like some elements, okay. Now alkali metals, okay, so these are the elements which are having similar properties, so they are placed under one group. Then alkaline earth metals, okay, so that is placed in another group. So like that, so the group of elements, they are placed together which are having similar properties. Okay, so we are calling it as classification of element. So so there were different scientists, okay, for forming the modern periodic table. Okay, so there were different scientists who came, okay, and what they did, they found out the different how the discovery of elements took place. Okay, so so there are different, you might have studied about the Dobrinier's triad, right? Then Newland's law of octave. So these were the different scientists, okay, who arranged the elements into different forms. Okay, and at last we succeeded with the modern periodic law. Okay, so what are the important things, points from this chapter? Okay, so Mendeleev's periodic table. So this is one of the important concept. So what was Mendeleev's periodic law? Okay, what was Mendeleev's periodic law? So Mendeleev's periodic law states that the physical and the chemical property of the elements are the periodic functions of the atomic masses. Okay, what did Mendeleev did? Mendeleev arranged the elements in different with the elements, okay, with the similar physical and chemical properties according to their atomic masses. Okay, according to the atomic mass. Atomic mass means what? The weight of the elements. Okay, so what did Mendeleev did? He arranged the elements. Okay, the elements which are having similar physical and chemical properties. Okay, and they are arranged how? With their increasing atomic masses. Okay, so what happened? So whichever the elements were having similar properties, they were falling, okay, in the same group, okay, in the same group, okay, after certain interval of time. Okay, and in Mendeleev's periodic table, remember that there were 8 vertical columns. Okay, there were 8 vertical columns, and they were called as what? They were called as groups. Okay, they were called as groups. This is about Mendeleev's. Okay, this is about Mendeleev's before the modern periodic table. So Mendeleev's periodic table is also important. Okay, so this also gave a major importance there. So Mendeleev's periodic table, what was in Mendeleev's periodic table? It consists of 8 vertical columns, and which were called as groups, and 6 horizontal rows, which were called as periods. Okay, 6 horizontal rows, which were called as periods. Now, what was the merit, what was the importance of this periodic table? Okay, because of the Mendeleev's periodic table, so the atomic masses of the elements were corrected. Okay, so correction was made in the atomic masses of the elements. Okay, and when they were framing the Mendeleev periodic table, what they did, there were prediction of new elements. Okay, there were invention of new elements taking place. So this was some of the important or merits, okay, importance or advantages of this Mendeleev's periodic table. Now, what was the disadvantages? What was the disadvantages of Mendeleev periodic table? So the position of hydrogen, okay, dihydrogen could not be explained. So the position of hydrogen, okay, position of hydrogen was not explained because hydrogen is having what? Hydrogen is having what? So it is similar to what? It is similar to it. It acts as a alkali metal also, and it acts as a halogen also. Okay. So because of that, modern periodic table. Okay, in the Mendeleev's periodic table, the position of hydrogen was not explained. Where is the hydrogen placed, or where is its place? Okay. Then in certain pairs of elements, increasing order of atomic masses was not followed. So after certain time, okay, after certain elements were placed, what was done? The increasing order of atomic masses, okay. So increase as the elements were arranged. So after some point, the elements were not arranged according to their atomic masses. What was Mendeleev's periodic table? That the elements were arranged in their increasing atomic masses. But after some elements, it failed. Okay, it failed to follow the trend. Then position of isotopes could not be explained. So in Mendeleev's periodic table, the position of isotopes. What are isotopes, students? Anybody knows what are isotopes? What are isotopes? The elements having same atomic number but different atomic mass. Okay, if I say hydrogen, okay, if I say the hydrogen, okay, so this is the isotopes of hydrogen, right? You can see here. So this is what? This is hydrogen. Okay, this is deuterium and this is tritium, right? Remember this? Okay, so these are the isotopes. So the position of isotope was not explained in Mendeleev's periodic table. So after the this what, because of the disadvantages of Mendeleev's periodic table, okay, a modern periodic table was taken. Okay, modern periodic table or modern periodic law, or it is called as the long form of periodic table. So what was the law? The modern periodic law states that the physical and chemical properties of elements are periodic function of their atomic number. Okay, it is based on their atomic number and not atomic masses. So this was the correction made in modern periodic law, which we are applying today. Okay, so our modern periodic law, what we are using today, it is based on this law. Okay, that the physical and the chemical properties of the elements are periodic function. Periodic function means what? After some time, you can see that the elements are falling, which are having similar physical and chemical properties, are falling in the same group or same period. Okay, because of their atomic numbers and their how they have arranged in their increasing atomic numbers. Okay, so because of this, on the basis of the modern periodic table, okay, what is done? The elements are arranged in their increasing order of their atomic numbers. Okay. So what does modern periodic table consist of? Remember that it consists of 7 horizontal rows, or they are called as the periods, 7 horizontal rows, or they are called as the periods, and 18 vertical columns or the groups. Okay. So what does your long form of periodic table or the modern periodic law consist of? 7 horizontal rows. Okay, like this, 7 horizontal rows, and like this 18 vertical columns or groups. Okay, so the group, what does a period? Now what does the period consist of? The period consists of the series of elements whose same value of n. N is nothing but your electronic configuration. Okay. And what does a group consist of? A group consists of a series of elements with similar electronic configuration having same number of valence electron. Okay. And as you go down the group, what will happen to the value of n? The value of n increases. Okay. So the period consists of same elements whose the value of n is same. And when you see the group, okay, it consists of the element which is having similar electronic configuration. But as you go down the group, what will happen to the value of n? It increases. So this is some of the points which you have to remember in modern periodic law. Okay. Then, so because the long form of periodic table is based on the modern periodic law, okay, this periodic table is free, okay, and it does not have any demerits or disadvantages of Mendeleev's periodic table, okay. In modern periodic table also, the position of isotope was not explained. Because why? Because the isotopes, what are isotopes? The isotopes are having same atomic number but different atomic masses. So because of that, in modern periodic table also, the position of isotopes could not be explained. Okay. Since the basis of classification is atomic number and not atomic masses. So altogether, what you have to remember is that modern periodic table, it is depending on what? It is depending on the classification is based on atomic number and not atomic masses. And because of that, the Mendeleev's periodic table was further not considered. Okay. Now, next is what? How is the classification done now? Okay. So the classification of elements is based upon what? Their electronic configuration. So how many groups are there? There are basically 4 blocks. Okay. The elements are divided into 4 blocks. Which are the 4 blocks? S, P, D, and F. Okay. S, P, D, and F elements. So they depend on what? They depend on the type of atomic orbitals in which the electrons are filled. So we know the above principle, right? In the last session, in the structure of atom, we have discussed what is above principle. What does above principle states you? In above principle, we see that the electron distribution takes place from lower energy orbital to higher energy orbital. Okay. So when we are filling up the electrons, okay, so the electrons are filled in the same atomic orbitals. They are falling in the same groups. Okay, the elements of the electrons of the elements falling in the same atomic orbitals, they are placed in the same group. Okay, suppose your sodium. Okay, suppose your sodium, it is having 1s1. Then your potassium. Okay, so 1s2, 2s2, 2p6, 2p6, and 3s1. Then potassium, okay, it falls in 4s1, like that. So the last electron in which it is falling, in which atomic orbital, so the group it is represented. So how many blocks are there? 4 blocks: S, P, D, and F. Remember this. Okay. Let us see this column now, this particular tabular. Can you see the tabular? Yes. Okay. Now, which are the different elements? Let us see. Okay, I've just zoomed in. Okay. So here, S block. Okay, in S block, what you can see? Okay, in the S block, what you can see here? In S block, the last electron is entering into which orbital? Into the ns orbital. And your s orbital, it starts from 1s to, okay, to 7s. So in any of this orbital, only s orbital, when the last electron enters, okay, so that is positioned into your s block. So the electronic configuration of s block is ns1 to 2. So the maximum number of electrons which can be filled in your s orbitals is how many? 2, right? S orbital consists of maximum number of electrons which can be accommodated as 2. So it is ns1 to 2. N is how much? N is 1 to 7. So the maximum number, s orbital is from 1 to 7. Which are the groups which are falling in s orbital? 1 and 2. Okay, which are the groups 1 and 2? Okay, which is the one? One is alkali metals. Okay, one is alkali metals and second one is alkaline earth metals. Okay, alkaline earth metals. Where it is falling, students? Where it is falling? If you see the periodic table, okay, to your left hand side. Okay, to your left hand side is your S block elements. Okay, to your left hand side. And what does this group consist of? It consists of metals. It consists of what? Metals. So if you have a periodic table at your home, okay, please check this. Please check this. So in your periodic table to your left hand side, you have two groups. Okay, two groups, and those are group 1 and group 2, which is the S block. S block. Okay, and group 1 is called as alkali metals, group 2 is called as alkaline earth metals. So together they fall in the S block elements, where it is placed in the left hand side of the periodic table. And what is the which are the elements? They are the metals. Okay, what category? They fall into the metals category. Okay, so this is about S block. Next we will see P block. P block means what? The last electron will enter into the p orbital. Okay, last electron will fall into the p orbital, and p will start from n is equals to 2 to 7. Okay, n is equals to 2 to 7. Please note it down, very important. The p orbital, okay, it starts from n is equals to 2 to 7. What is the electronic configuration of p orbital? Okay, ns2 np 1 to 6. So the maximum number of electrons which can be filled in p orbitals is how many? 6, right? So the maximum number of electrons which can be filled is 6. So the electron filling can takes place from 1 to 6. So which are the groups which are falling in your p block element? It is from group 13. Okay, group 13, 14, 15, 16, 17 and 18. Okay, so these are the 6 groups which are falling into your p block element. Okay, now when you see the periodic table, okay, where is the, this is your S block, where is your p block? To your right hand side, 1 2 3 4 5 6. Okay, so this is your p block element. So where is your p block element? On the right hand side. So now these consist of what in the p block element? So some are metals, some are non-metals, and some are metalloids. Now you know what are metals, what are non-metals. What do you mean by metalloids? Metalloids means what? They are having the properties, okay, of metals as well as non-metals. Okay, so metalloids means what? They consist of, they are having the properties both. They act as a metal also, they act as a non-metal also. So in p block you have metals, you have non-metals, and metal. Remember this, very, very important. Electronic configuration is very important. Okay, and what are the groups? Group 13 to group 18. Next is d block element. Next is what? D block element. D block element, the last electron will enter into the d block. Okay, n minus 1d. So n minus 1d orbital. So the last electron will enter into the d orbital, n minus 1d orbital. So the value of n can be from n is equals to 4 to n is equals to 7. N is equals to 4 to n is equals to 7. Remember this. Okay. Now what is the electronic configuration? What is the electronic configuration? It is n minus 1 d 1 to 10. So how many maximum number of electrons can be filled in the d orbitals? Okay, they are 10, right? 10 number of electrons can be filled in your d orbitals. So maximum number, so it is n minus 1 d 1 to 10. Okay, and ns 0 to 2. So this is the electronic configuration. Now what are the d block groups? So it is from group 3. Okay, group 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Okay, so S block group 1 and group 2, P block from 13 to 18. In between this is your D block element. So group consists of what? From 3 to 12. Okay, 1 2 3 4 5 6 7 8 9 10. So 10. Okay, so 10 groups are present in your D block elements. So from 3 to 12. Where is its position? Yes, where is its position? So here is your P block, here is your S block, here is your P block. In between, okay, in between is your what? Is your D block element. So it is in between here. Here you can see with the pink line. Okay, so in between what is present is your D block elements. And what does it consist of? It consists of transition metals. What it consists of? Transition metals. Okay. Next is your F block. Next is what? F block. Okay. The last electron is entering into what? Your F orbital. Okay. That is N minus 2 F. Okay. Orbital. So what is the value of N? N is 6 and 7. Okay. N is 6 and 7. What is the electronic configuration? Very important. N minus 2 F 1 to 14. So the maximum number of electrons which can be accommodated in your F orbital is how many? 14. Okay. So n minus 1 S 2. Okay. Then n minus 1 P6, n minus 1 D02, 1 NS2. So this is the electronic configuration. Okay. Now where it is positioned? Where it is positioned? So it is related to group 3. So here only. Okay. So these are called as transition. These are called as inner transition. Just below the this your D block. So this is your S block. This is your P block, D block. So just position here. It is position your F block. Okay, F block elements. So they are placed separately below the main periodic table. So this is the position of your periodic table. I hope you have understood this. Very important. Okay. So please refer the periodic table as I am explaining you. Okay. Fine. So how many? There are 3 series of D block elements. Now you can see that the D block are consisting of 10 groups, right? 10 groups are present in D block. So there are 3 series also. 3 series are present. Which are the 3 series? 3D series, 4D series, and 5D series. Okay. So in 3D series, what you have? You have the elements from scandium to zinc. Scandium 21 to zinc 30. Then 4D series, you have yttrium to cadmium. Okay, that is 39 to 48. And 5D series, it consists of your lanthanum, hafnium, okay, and 2 mercury. So these are the 3 series which consist of the D block elements. And your F block element, it consists of 2 series, okay, and 2 series. Each series consists of 14 elements. Each series consists of 14 elements. First series is your 4F series. Okay, it starts from cerium to lutetium. Okay, that is, they are termed as lanthanoids. Okay, they are termed as lanthanoids. And your 5F series, it starts from thorium to lawrencium. Okay, thorium to lawrencium, that is from 90 to 103. And these are termed as actinoids because in the same group. Okay, now when you see the periodic table, this is your S block, this is your P block. In D block, okay, there are what? Transition elements also, and separately your inner transition elements are also placed. Okay, so which are the 3 series in your D block? 3D, 4D, and 5D. Okay, and in your F block, 2 series are there. Each series consists of 14 element each. Okay, that is your 4F and 5F. 4F series are called as lanthanoids. Okay, and 5F series are called as actinoids. Okay, so these are the very important series. Okay, now when we see the you can see here the periodic table. Yes, so here you can see the periodic table. Yes. Okay, so these are the different groups. So group 1 and 2 S block, group 3 to group 12 is your D block. Okay, and separately down is your F block. Group 13 to group 18 is your P P block elements. Okay, and when you see the electronic configuration, okay, so here hydrogen, helium, Okay. So how many periods are there? 7 periods are there. Okay. So these are the short periods, that is from hydrogen and helium, two elements. Then second period is from lithium to neon. Third period, okay, it consists of sodium to argon, then potassium to krypton, rubidium to xenon, and the sixth period, cesium to radon, and the fifth is from uh, FR to incomplete. Okay, so still some of the elements are to be discovered. So whichever the man-made elements are there, so that are, you can see in the periodic table last, okay, some of the elements blocks are kept incomplete, right? So still some of the elements, okay, whichever are invented are added there. Okay, now what are these? Okay, now we'll study some of the important. So this what periodicity properties. Okay, what is ionization potential? What is the important? First one is the ionization potential. No, first we'll start from the atomic this, okay, atomic size. Now when we consider the atomic size of the elements, okay, so from left to right, when you go from left to right, what will happen to the atomic size in the period? Okay, in the period, when you go from left to size, the atomic size will decrease. Okay, it will decrease. Okay, because in the same shell the electrons are added. Okay, what will happen to the intermolecular forces of attraction? It will increase, and what will happen? The nucleus will tend to attract the electron towards itself. So as a result, as you go across the period, the size will decrease. And as you go down the group, what will happen to the size? It will increase. Why? Because there is addition of new shell. As you go down the group, there will be addition of new shell. So like this, the addition of new shell takes place. So because of that, the distance between the nucleus and the outermost electron will increase. Okay, the attraction decreases. Because of that, the size increases. So these are some of the important points. So based on this, let us now solve some questions. Okay, and remaining properties we will see as the questions will come. Okay, fine. So let us start with the questions now. Yes. So let us start. Okay. So this is the first question. So an element with atomic number 21 is. So we have just seen the elements which all fall in which group. Okay. So now you have to answer this very simple question. And elements, so this chapter, okay, classification of elements and periodicity is very easy chapter actually. Okay. So very scoring chapter. So don't leave this chapter. So study very theoretically. Okay, so very important chapter. So let us see. An element with atomic number 21 is which one? A transition element, B alkali metal, C halogen, and D representative elements. Yes, the element with atomic number 21 is what? Hema has answered as A. Okay, what about others? What about others? So if you don't know what is the, okay, Fatima, Safra Fatima has answered as A. Okay. So if you don't know, okay, suppose students, if you don't know now which is this, okay, the element with a atomic number 21. What you have to do? You have to put on, you have to use the above principle. Okay, you have to use the above principle and you have to feel the electrons. Okay, according to the above principle. So let us start with the filling up of electrons. If you don't know, okay, so how it will start from ns. So s electron, maximum number of electrons will be 2. So 1s2, then comes your 2s, 2s2, then comes your 2p, 2p6, then comes your 3s, so 3s2. Okay, so count, so as you're entering, count also. Okay, 6, 7, 8, 9, 10, 11, 12. Okay, so still, so then will be your after 3 years 3p. So maximum number of electrons is 6. Okay, so 12 plus 6 again will be 18. Okay, so 18, then 4s will come, 18, 19, 20. Okay, after 4s the electron will enter into 3d. So 3d maximum electrons will be 10, but now we are left with only 1, so it is 1. So where it is entering, you can see that the last electron is entering into the d orbital. Okay, it is entering into the d orbital, and d orbital or D block element, and they are also called as what? Transition element. They are called as what? Transition element. What is alkali metal? Alkali metal means they represent your S block element. Okay. What is your halogen? Halogen means they are the group 18. Okay. They are alkali metal is group 1. Okay. And which block it is? S block. Halogen means they are group 18. Which block? P block. And what do you mean by representative elements, students? Anybody knows what are representative elements? Yes. What are representative elements? Very important. 1 mark question. 1 mark question. Very important. Yes. What are representative elements? Anybody knows what are representative elements? Okay, remember this. Remember this. Please note it down. Okay. S and P block. Okay, your S and P block elements together, they are called as what? They are called as a representative element. So a 1 mark question. 1 mark question. What are representative elements? What are representative elements? S and P block elements. Okay. S and P block elements, they are together called as representative elements. Okay, which is that S and P block elements. So don't forget this from the classification of elements. Okay, S and P block, they are called as elements together. They are called as what? Transition elements. So which is our answer for this one? It is option number A. Okay, so first one, our answer is option number A, that is transition elements, because it is entering into the d orbital, and d orbital, they are called as what? They are called as the transition elements. Okay, next one. Okay, this is based on ionization potential. Fine. Let us go for the fourth one. Okay, fourth one. The oxide of an element whose electronic configuration is, okay, an oxide of an element whose electronic configuration is 1s2, 2s2, 2p6, 3s1 is. So, which is the element? 1s2, 2s2, 2p6, and 3s1. 6, 7, 8, 9, 10, 11. Okay. So, which is the element with 11 atomic number? Yes.
Sodium.
11 is your, yes, sodium. Okay, sodium is the metal. So the oxide of metal, okay, element. So if we found the oxide of this metal, so it can be your sodium Na, oxygen O2. Na plus 1. Okay, so when we see the oxide of this metal, so they have asked whose electron, so oxide of whose electron, so what it is? It is amphoteric in nature, it is basic in nature, it is neutral, acidic in nature, or it is neutral in nature. Now, what do you mean by acidic? Acidic means whose pH is below 7. Okay, And basic means what? Whose pH is above. So acidic, when we consider the acidic, okay, so the alkali metals, okay, alkali metals are always basic in nature because okay, they are basic in nature, alkali metals, okay. So they are option number B. So the element, which is the element, it is sodium, and this is a alkali metal, and alkali metals are basic in nature. So they are strongly basic in nature. So option number B is the answer. Option number B is the answer. Okay, let us go for the next one. Generally, okay, this is about ionization only, electronegativity. Okay, now let us see about this one. What? Atomic size. Okay, this one. Next question here. The correct arrangement of ions in the increasing order of their radii is, okay. Now when we see the atomic radii, the first property when we just saw, so what I told you, as you go across the period, so this is the period and this is a group. So as you go across the period, what will happen to the radius? It will decrease. And as you go down the group, what will happen to the radius? It will increase. Okay. Okay. Now here, which are the elements? The current, or so they are in the ions forms. Okay. Can you tell me how is the arrangement? Sodium Na plus means the number of electrons are 10. Okay, because Na plus, so plus means 11, minus 1 will be 10. Okay, so it will be Na is what? Na is your 10. So the number of electrons are 10 here. 10 are there. Then Cl minus. Cl minus means what? The electrons are 17. Okay. Now minus means it is 18. Then Ca plus 2. Ca plus 2, atomic number is 20. Okay. Atomic number is 20. So what will happen here? It will be 18 because it is plus 2. So minus you have to do 2. Now, what is the increasing order of this? So here you can see this is 10, this is 18, this is 18. Okay. Now, which is, let us see the second one, Na plus 2. So when we see Na plus 2, okay, now it will be, Na will be 9. Okay. Then K plus is 19. Okay. So plus, this will be 18. Then number of electrons will be 18 here. Then sulfur, okay, sulfur is 16, minus 2 means again 18. So here also there is no proper increasing order. Let us see C option. Okay, your sodium is again 10, okay, because Na plus. Then Al plus 3, aluminum is 13. Okay, then this is how much? 13 minus 3 will be 10 again. Then Be, beryllium, 4. Okay, 4. So again it is 2. So here also there is no proper uh, increasing order. Okay, let us see next one. Cl minus. Okay, if we see Cl minus, Cl minus, Cl minus is what? Wait. Now Cl minus, if I see 17, so this will be 18. Then F minus is fluorine is 9 plus 1 10, and sulfur is 16 plus 2 is 18. I think there is some mistake. Okay, here I think this is calcium. Option B, if you do this is calcium because Na will not exist as plus 2. Okay, so this is calcium, I think. So now you see for B option, if you take calcium plus 2 here. Where it went? Here, no? Calcium.
18 will be there.
Okay, let us see for calcium here. Calcium is 20. Okay. Minus 2 will be 18. Potassium is how many? 19. Okay. Then here it will be again 18. Sulfur is 18. Okay. Now, when you see the correct arrangement of ions in the increasing order. Okay. Now, here if you see, they are having same electrons. When you have same electron, what it is called as? Yes, when you are having same electrons, what it is called as? When you have same number of electrons, we have studied this in structure of atom. Okay, when we have same number of electrons, they are called as what? They are called as isoelectronic
Isoelectric.
species. Yes, very good. They are called as isoelectronic species. Now here, when we see the calcium plus 2, K plus and S minus 2. So these are what? These are all isoelectronic species. Now when you have a isoelectronic species, what will happen to the radius? The radius will decrease. Okay. Why? Because now here your nucleus is present. Okay, your nucleus is present. Your nucleus is present here, and the same number of electrons are present. The same number of electrons are present here in the all the three system. Okay, so what will happen to the nuclear charge? The nuclear charge is increasing. Okay, the electrons are removed, but the nuclear charge is increasing. What will happen to the radius? Because the nuclear charge is increasing, the electron will tend to pull the electron towards itself. Okay, the your nucleus will tend to pull the electron towards itself. So as a result, what will happen? The yeah, there will be increase in the nuclear radius. Okay, so calcium plus 2 will be less than your K plus and then S2 minus. Okay, because in your calcium 2 electrons are removed. Okay, 2 electrons are removed. So the nuclear charge, okay, is what is happening? So it will tend to okay, so like this. Now, when K plus is there, 1 electron is removed. So 1 electron, what will happen? Again, the force will be more. So all the charge, complete nuclear charge, what it is doing, it is completely attracting the last electron. Okay, it is completely attracting the last electron. Now, again, when you are having your last one, that is sulfide S2 minus, okay, what is present now here? Again, the number of electrons, 18 electrons are present. So here, what will happen to the charge? Again, what will happen? It will tend to pull the electrons here. So there will be increase in the size. So option B. So isoelectronic species, what is happening? The radius is decreasing as the nuclear charge is increasing because of the nuclear charge. Okay. Now, in between questions which I have left, so I have not explained you the ionization enthalpy. So because of that, I have left the in-between questions. So I'll be doing that questions also in between questions. Okay. Because I have to explain what is ionization potential. So first I will see what all questions are present. Okay. On basis of what all things I've explained to. Then I will go to the, yes. Can you tell me? We will go for the 13th question. The orbital nearest to the nucleus is. Which is the orbital nearest to the nucleus? So this is based on the above principle. Okay, this is based on what? Above principle. So 1s, 2s, 2p, okay, 3s, 3p, 4s, 4p, okay. Then like that. 4s 3d, here 4s 3d will come, 4s 3d, then 4p, okay, so 4f, like that. So which is the orbital nearest to the nucleus? 4f is here, okay, 5d is after this, your 7p will be after this. So which is the nearest? Yes, option C. Okay, option C. Yes, very good. 4s, very good. Okay, 4s is the nearest. You can see. right? 4s is the nearest, so 4f is here. So this is after 4f your 5d will come, after 5d your 7p will come. Okay, if you write the above principle, fine. Let us see some more question, then I'll explain you what is ionization enthalpy. Yes, so here most of the questions are based on ionization enthalpy. So let me first explain you what is ionization enthalpy, because ionization enthalpy is very important concept. Okay, when you see the ionization enthalpy, it is a very important concept. Okay, so I've explained you these all things. Okay, so I have explained you the first here, atomic size. Okay, atomic radius. How, what will happen to the atomic radius as you go across the period? What will happen? It will increase, decrease. Sorry, and as you go down the group, what will happen? It will increase. Okay, so there are different atomic radius when we are discussing the this. Okay, when we are discussing our atomic radius. So different radius, these are there. Covalent radius, metallic radius, and van der Waals radius. What is this covalent radius? Okay, when we discuss about covalent radius, it is the half of the distance between the centers of the two similar atoms joined by a single covalent bond. Okay, this is generally used for non-metals. So where it is used, these are generally used by non-metals. Okay, so where now suppose two atoms are there. Okay, two atoms are there. Suppose we have both chlorine atom. Chlorine atom is what? It is a non this what? Non-metal. Chlorine is a non-metal. So these are the two chlorine atom. So it is the half the distance between the centers of the nuclei. So here, if I take the nuclei of the first element, so this is a nuclei of the first element. This is a nuclei of the second atom. Sorry, not element. When I'm so this is the nuclei of the first atom. This is a nuclei of the another atom. So, okay, so this is nuclear means what? It is present in the center. Okay, it is present in the center. So what is, so what we are doing? We are taking the center nuclei and we are joining it. Okay, so this is the half of the distance between the centers of a nuclei of two similar atoms. Okay, and it is joined by a single covalent bond. Okay, so this is called as a covalent radius. This is called as covalent radius. Okay. So where it is present? Covalent radius in the non-metals. In the non-metals. Now, second one is the metallic radius. Second one is what? Metallic radius. Let us discuss about metallic radius. It is half of the intermolecular distance between the two nearest atoms in the metallic lattice. It is generally used for metals. Similarly, again, if I take two metals, I'll take sodium metal. I'll take sodium metal. Okay, I'll take sodium. Now, if I consider the nuclei, okay, if I consider the nuclei of these elements, okay, now here it is what? It is half the intermolecular distance between the two nearest atoms. So this is a metallic radius. So metallic radius, where it is present in the metals. Okay, it is metallic radius. Okay, where it is present in the metals. I hope these two are these are understood. Next is van der Waals radius. Next is van der Waals radius. What is the okay? What is the van der Waals radius? Let me explain you. Now, van der Waals radius, it is the internuclear distance between the two nearest atoms belonging to the two adjacent molecules in the solid state. Okay, now this is between the two molecules. Suppose I have HCl, I have HCl. Okay, so this is what? Now here, suppose I have two molecules, HCl and HCl. Now, HCl means what? Your hydrogen. Okay, here your chlorine, or which one I'll take? Okay, your hydrogen, and here is your chlorine. Okay, here is your chlorine and your hydrogen. So this is what, these are the two molecules. Okay, so hydrogen nuclei, chlorine nuclei, chlorine nuclei, hydrogen nuclei. We know that cations will be smaller in size as compared to the anions. Okay, so I have taken here a molecule. Now here, when I say the van der Waals radius, it is between what? It is the distance. Okay, now this is the your half intermolecular. Okay, now it is the distance between these two. Okay, so this is called as what? This is called as the van der Waals radius. This is called as what? Van der Waals radius. So van der Waals radius between these two is, we have seen, okay, between these two is the covalent radius. Okay, between these two is covalent radius. So half the distance between the nearest atoms of a same molecule. Okay, this is called as the van der Waals radius. So remember the definitions. Remember the definition, very important. So this is a van der Waals radius. Okay. Next concept we will see. So here what are important are is the your this, okay, all the periodicity properties. Next is the ionic radius. Now where is this ionic radius present? Ionic radius, suppose I take uh, Na plus, okay, Na plus, this is your Na plus and your Cl minus. Cl minus. Okay. So it is a distance between the nucleus and the outermost shell of an ion. So this is a distance between the nucleus and the outermost shell of the ion. This is called as what? It is called as the ionic radius. This is called as what? Ionic radius. So ionic radius, what will happen as you go from top to bottom? It will increase. As you go from left to right, it will decrease. Okay. So this is about your ionic radius. Next, we will see what is ionization potential or what is ionization energy. Okay, it is the amount of energy which is required to remove the electron from an isolated atom in the gaseous state. Now, suppose I take sodium. When I say sodium, what is the electronic configuration? 1s2, 2s2, 2p6 and 3s1. Okay, now suppose I am writing the electron distribution. In the center, you have your nucleus. Okay, then the electron distribution will start. So 1s and 1s. Okay, so in the first two electrons are placed. In the first two electrons are there. So this is one. Okay, so this is your nucleus. Okay, this is your nucleus. Your two electrons are there. Then in your next orbital, 8 electrons are present. That is your 1, 2, 3, 4, 5, 6, 7, 8. Okay, these are the 8 electron. Then in your third shell, okay, you have one more shell. This is your third shell. Now here, how many electrons are there? How many here? 1 electron. So 1 electron. So easily the electron can be removed from the outermost shell because only 1 electron is present. So the energy, whatever the energy is required to remove this electron from an isolated gaseous atom, that energy is called as the ionization potential. Okay. Now, when this one electron is removed, what will happen? That means the electron is lost. So what we write? We write Na plus and 1 electron, right? Now, if I want to remove one more electron, okay, now I want to remove next one more electron. So how I am going to remove? I am going to remove from this shell, okay, from this shell. Now, can you tell me what the energy required will be less or more to remove the electron from the next shell? Yes, can anybody tell me the energy required to remove the electron from the next shell? Now I have removed this. Okay, what is this? To remove this electron, it will be easy. Why? Because there is only one electron. So it can be, it is what? It is a minimum amount of energy. Okay, minimum, very minimum amount of energy required to remove. Now, when I want to remove one more electron from sodium, Now next electron, it should be removed from this orbital. Okay, from out of this 8 electrons, one of the electrons should be removed. So that time the energy required will be less or more. I want that much. Yes, it will be less or more. Yes, what do you think? The energy required. So here there are 8 electrons. Remember that 8 electrons are there and nucleus is present. Okay. So nucleus is positive charge, electrons are negative. So whenever you have positive negative, attraction will be more. So what will happen? Energy required will be less or more. Yes.
Less, ma'am.
How less? Now,
More, ma'am.
okay, now you're yes, the energy required will be more. Why tell? Now, suppose you are single, you are standing alone. Okay, alone you are standing. That time, you can be easily kidnapped, or in a group when you are standing, that time you will be easily kidnapped. Yes. Suppose person has come to kidnap you. Okay, when you are singly standing, okay, it will be he can easily he can able to take you away. Okay, but when you are standing in a group, okay, it more hurdle will come for you. Okay, it will be very difficult for him to trap you. So here also, when you are when you want to remove the single electron, okay, now single electron, the energy required will be less as compared to when you are in a complete shell. Okay, and that too the shell is nearer to the nucleus. So what will happen? The attraction between the nucleus and the electron will be more. It will tend to hold the all the electrons more tightly. It don't want. Now one person has already left the group. Okay, suppose you have a group of 7. Already one person has left your group. Now what others will do? Others will hold them tightly. Okay, they'll not give others to leave. So like that, same way will apply here. What will happen? The nucleus will not tend to leave these other electrons. So that time when you are, okay, fine. If they take the electron also, the energy required, what will happen? The energy required will be more. Means what? Now when you are removing the first electron, the energy, suppose it is IE1. Okay, ionization energy 1, and when you are removing the second electron, it is IE2. So IE2 will be more than IE1. Okay. Again, if I removing the third electron, again, what will happen to the third electron? The energy will be more. So subsequently, as you are removing the second, third, fourth electron, the energy will go on increasing. So ionization potential, when you are removing the first electron, it will be less. Okay, the energy required will be less. Minimum amount of energy which is required to remove the outermost electron. Okay, so when we are comparing, if they give you IE1 is greater or IE2, okay, you can easily say that IE2, okay, because ionization energy, that is IE2 will be always greater, because you can see here the electrons are present here in the 8. So it is very difficult because they are bounded very tightly. Okay. So the energy required to remove from this shell, it is very difficult as compared to the first. Okay. So again, in the next class also, first I'll start with the ionization potential concept, and then we are going to proceed with the question. So in this chapter, ionization potential, electronegativity, ionization enthalpy, ionization affinity. Okay, so these are some of the important concepts. So based on this, the questions will be asked. Okay, I hope little at least you have understood today about the ionization potential. Okay, so some more example I'll give you in the next class so that it will be uh, fixed in your mind. Okay, fine. By this, any doubts you have? Yes. So whatever the questions I have left in between of ionization potential, it will be covered in the next. Okay, because I have not explained the concept. So I thought of taking this question later. Okay, fine. So the remaining questions and the remaining concepts will be discussing in the next class. Okay. So by this, I shall end this session here. Okay, we'll meet in the next week. Thank you.